Thank you very much for taking your time out. Today, we're going to talk about the residential hybrid single-phase systems. We're going to go through 2 levels of training. The basic training, which is really an introduction to the product and the architecture. And then we'll go through some of the more intermediate training, which talks about things like wiring it into the home, as well as some of the most important settings that we're going to look at. If you have any questions, please raise your hand. Daniel, if you don't mind, if you can just keep an eye on it, and if I'm engaged in a presentation at the moment, just stop me, let me know, and we'll answer your questions as we get to them. There will, of course, also be a little time for Q&A at the end of each of the sessions. So with that, let's get going. So we're going to start with the product introduction, and let's talk about it. What is it? Well, what we have is a single-phase hybrid inverter, which is paired with high-voltage lithium-ion batteries. Okay, it's from a single manufacturer or supplier of all the kit that comes in it, being Sungrow. And what it includes is the hybrid single-phase inverter, high-voltage lithium batteries, the battery management system, the protection between the inverter and the storage unit, a power meter, a communications dongle, which has got both Wi-Fi and Ethernet on it, and all of this with one part number and from one accountable party. So one of the biggest things that we've seen in the industry is people will go and do installations, and if there's a problem, everybody wants to blame everybody else. In this particular case, if there's a problem, it's one phone call, one source, one decision, one software, one point of accountability. Okay. What does it do? Okay, so this is not a UPS. It's not a backup system. It's not a solar system. It's an energy management system. On the PV side, it converts energy from the panels into usable energy in the home at 230 volts, being single phase. It also stores energy either from PV or from the grid when desired to do the following 4 functions. The first one is during outages in case there's load shedding, right, or grid failure for whatever reason. The second thing is during peak times, we can do load or peak shaving. So we can discharge battery power to number 1, help the country and ease the load during those peaks. And number 2, especially if you're on a time of use tariff for whatever reason, we can cut that down. The third thing it does is during non-sunshine hours, is it reduces your energy imported from the grid. Unlike a lot of systems where you don't want to cycle the batteries, in this system, you do want to cycle the batteries. The warranty is 6,000 cycles. So in other words, at 1.5 cycles a day, that's 10 years worth of life, right? You actually do want to cycle them. The goal is take solar power, store it during the day, use it not only during the day, but for the rest of the night as well, before you spend a cent on Eskom. We have a white paper which we delivered last month where we actually compared the differences in the costs per kilowatt hour per cycle of the batteries. And it turns out that the cost per kilowatt hour stored and used from these systems comes out to roughly R1.66. So the choice is to use your solar power in the day and store the extra and use it at R1.66, or to go and buy new energy from Eskom at R2.68 or whatever you're paying. Ian, absolutely, thanks. We do have a link, and I think Daniel will post the link to the presentation of that white paper for you. Okay, and then of course the fourth option is when there's no grid attached whatsoever, we can actually form a grid in a microgrid mode where it will operate just with a diesel generator and run your clients completely off grid. Ryan, the cost was about R1.66 per kilowatt hour of stored energy. So that's, if you break it down, it's basically the white paper, what it discusses is the cost of lead acid, of lithium ion, of the various different battery sources, gels, so on. And it does a comparison not in terms of capital cost for capacity. It does a comparison in terms of your cost per cycle per kilowatt hour of usable energy. And it actually gives a totally different picture of how we can use batteries these days. And then, of course, the last thing the system does is it displays all this information on your phone, your laptop, your computer, a big screen in your building, wherever you want it to be. Okay, so how does it do it? And we're going to spend quite a while on this because the architecture is slightly different to what a lot of people are used to, right? The slides coming after this explain the system architecture a lot simpler than the diagram below, right? The diagram below is an advanced sort of engineering diagram, but what we're going to do is we're going to discuss how it does it. So that's the inverter. Can everyone see my little dot? Here we've got the AC side, our sine wave, and here we've got the DC side of the inverter. We've got 4 connection points, excluding the comms on this. The first connection point is labeled grid port, right? The grid port is where we connect the inverter to the home's network, your existing DB. And also it's where the non-essential loads would be positioned before we connect to the inverter. So of these non-essential loads, you would probably have a geyser, a stove, underfloor heating, maybe a pool pump, something like that. Okay, these are the loads that when there's load shedding, you don't need them to run. Some key points here. 63 amp feed from your mains. The manual says 40, right? You can use a 63 amp, and we would recommend a 10mm cable in order to carry all of that current, because this connection point is bidirectional. Okay, it's got type 2 surge protection built in, and we can import energy and export energy through this port. Okay, it's a bidirectional energy flow, and this is really, really important for the rest of the discussions this morning. It's also NRS compliant, so we've got the certificates in place, and it is on the City of Cape Town's list, right? So that's the grid port. The second option is where we connect the PV panels. Now, those we're going to connect on the DC side. Okay, on the PV panels, we've got 2 MPPT inputs on the unit. They are MC4 connectors. You'll see 4 little connectors, or in other words, 2 pairs, male and female, for each of the MPPT inputs. They are 600 volts DC inputs each. The amazing thing about that is it gives us a maximum DC power of 13 kilowatt peak we can feed into the single phase unit, right? 13 kilowatt peak, which is massive. There's a DC isolator included. I haven't shown it or drawn it on this drawing, but it's important to remember that there is a DC isolator there, so you can isolate and take those arrays into open circuit from the unit itself. And just like on the AC side, we also have type 2 surge protection built into it on the DC side. Okay, the MC4 connectors also come in the box for the other side of your cable. So from your PV panels, the MC4 connectors that you would connect to your strings coming in are included in the box. You don't have to go out and source extra of those. So that's our PV input. The next input we've got is the battery input. Okay, it's the battery storage. Again, high voltage lithium ion, and the stacks range anywhere from 9.6 kilowatt hours up to 19.2 kilowatt hours of storage. The units come with a base. You then just stack each cell on top. You put the protection unit in the side, connect up your cables, drop the battery management system on top, which comes in the lid, and you're effectively ready to commission. I'll show you some pictures of those a little bit later, and the entire installation time is so fast on this. The figures that we've quoted, the 9.6 to 19.2, that is usable energy, right? That is not capacity. That is usable energy for the client. Certainly the capacity is higher, but the battery management system in the batteries and the inverter are unconcerned about the actual capacity. Rather, they just focus on what is usable. Okay. All your protection and your communications are included in the supply box. So this includes your DC breaker, which slides into the side. It includes your communications cable. It includes your wireless dongle so that you're going to communicate with your home network so that you can see everything on your phone, your laptop, your computer. That all comes in the box for you. And all you need to supply with this is about 1 meter each of red, black, and earth cable, 6 millimeters. The fact that it's a high voltage lithium ion system means that we don't need to have 25 mil DC cable. We don't need to have big fuses. We don't need to have all these other things, a whole DC box in between. It's literally the cables come out. The SunClicks connectors are provided in the box for you. So you put your SunClicks connectors on the red, on the black. The lugs are supplied with you for the earth, are supplied in the box for your earth cable, both sides. And then you just earth that into the chassis. So really, there's not much for you to do other than to provide 20, 40, 60 odd rands worth of cabling, which you should have on site for your PV panels anyway. Okay. Really, really, really neat. Makes the whole installation fast. Offsets a huge amount of cost and speeds up the entire installation time. Okay. Why do we use SunClicks connectors here? Well, we've got MC4 connectors here. So we do this because the cables look the same so that we can't plug the wrong cables into the wrong ports. Okay, slightly different connectors. The SunClicks connectors cannot fit into there, and your MC4 panel connectors cannot fit into your battery port. Okay, just for safety and ease of use. And then finally, the backup loads. Now the backup loads, you can see we've got drawn here, we've got lights and we've got plugs. It could be plugs, could be any other equipment which requires earth current, leakage. So your residual current device or your earth leakage device. Please make sure that if you have any plugs running on here, that you have to have an RCD in place. Normally we separate the lights out so that if there is an earth fault somewhere, and especially at night, the client's still got lights and they can see everything that they need to see. Okay, so this is our backup loads coming out. This is in one direction only, whereas the grid port is bidirectional. The backup port only operates in a single direction. We've got a 10 millisecond transfer time on the 6 kVA single phase unit. There is a digital out option for load control. We are not going to cover it today, not even in the intermediate. Normally we would cover that in the advanced session, but please just be aware that there is digital out option available. So you can instruct the system to pull out contactors or to support your client in load control. In fact, there's actually 4 digital, I think there's 4 DOs and 1 or 2 DIs as well. Okay. And when we talk about the 6 kVA unit, we are only referring to this backup port. It's 26 amps on the single phase unit. Okay. So a lot of guys will come in and say, oh, it's a 6 kVA unit. It's not a 6 kVA unit. The 6 kVA refers just to the amount of load that we are going to run on batteries during failures. The majority of our clients actually don't exceed 2, maybe 3 kilowatts on their loads because during outages. And the main reason for that is nothing to do with here, nothing to do with the inverter. This part is very cheap. It's because they don't want to provide the battery power and the PV power to carry those loads. If you're going to run 10 or 8 kVA loads for 4 hours, you're going to need a huge battery stack, right? Of course, we can parallel a couple of these to allow for that. But in most of our cases, our clients aren't pulling more than 3 kVA during outages. Okay, so what makes this so exciting then? Well, we've got potentially 13 kilowatt peak. At the same time, we can charge the batteries with 6 kVA. We can run 6 kVA of loads, and we can feed any excess back through here, all at the same time. Okay, all at the same time. So what does that mean? Well, maybe I've got my geysers and a stove here. Maybe my batteries are full. Maybe I'm pulling 3 kilowatts here, but I've got another 6 or 8 or 10 or whatever it is available to me. The fact that I've got 63 amps here means that I can, without curtailing my PV, I can feed back and I can run all of these loads, right, off my PV or off my batteries, in fact, if I wanted to, right? Because if we're running in self-consumption mode, I may say I don't want to use Eskom. I would much rather use my batteries for here. Okay, this is it's a defining different option or a different factor for this solution, which not a lot of other systems in the world have got, and in fact, none that I'm aware of that are doing it in mass from a tier 1 manufacturer locally. Now, how do we do that without exporting to grid? Well, in your box, there's a meter supplied, and that meter gets installed here. That meter measures 2 different points. It measures voltage and it measures current. It uses the voltage to determine if and when I've got a grid failure. Of course, if there's 0 volts, I go back and I say I'm now in an off-grid state, and I move the inverter from on-grid operation to off-grid operation. The second thing it does is it looks at the current, and as long as current is flowing in this direction, right, from right to left, in other words, into the inverter, I know that I'm okay to not curtail my PV. As this current approaches 0 and potentially starts to move from left to right, in other words, exporting, I curtail my PV production so that I can still feed my non-essential loads with my own solar power or my own batteries, and I still meet all the compliance of not feeding back to grid. Okay, this is really, really important because it allows your return on investment to be far superior to a lot of other systems that don't have that option. Okay, are there any specific questions on this that we need to answer now, or can I move on to the next?
None at the moment. We
Right.
can move on.
Perfect. Okay, so let's talk about now the different operating modes that we do have available to us. In the inverter, when you're doing the setting up or when you're doing the analysis, you'll actually find that there are quite a few different modes of operation. I think there's a total of 7. 4 of them we don't use. I think one's for Italy, one's for Australia. A couple of others are for much more advanced settings that we're going to use. We are really going to focus only on 3 modes. Either self-consumption mode, compulsory mode, or microgrid mode. The most common mode is what self-consumption mode does is priority is always given first to PV. What we are trying to do is we are trying to extract the most amount of value from the attached solar system on an annual basis, on a daily, weekly, monthly, annual basis. So priority is always given to PV first. If there's any additional demand, it's then pulled from the battery, right? Now, that cycles all the way down to the reserve state of charge, for example, 40%, which you can set. We'll talk more about the reserve state of charge in a little bit, so long as grid is present. So in other words, you may say, well, why am I running my non-essential loads from battery? Well, because at a Rand 66 or whatever the price ends up being, it's cheaper than bringing in new energy at 2 Rand 68, especially considering the fact that later on that day or tomorrow morning, the sun's going to come up again and recharge our batteries for us. That reserve state of charge is a limit that we can manually set to say, do not go below this limit in self-consumption unless my grid falls away. In other words, unless I have a grid failure and or load shedding. You know, the inverter doesn't distinguish between the two. The moment that happens, that reserve state of charge falls away, it recognizes the grid is gone, and it'll start moving down. Sean, I'll come back to your question a little bit later. Thank you, I have seen it. And then finally, grid makes up the difference. So for example, if we were running, let's say the home was running at 12 kilowatts, well, let's say 9 kilowatts, for example, it may only be a 6 kVA on the backup loads, but potentially we've got 3 kVA running on our backup loads, and we've got we've got 2 geysers running on my non-essential loads at 3 kilowatts each. We could be having 9 kilowatts through the house. Maybe I've got 4 kilowatts available to us from solar. I could discharge my batteries at another in fact, I can discharge batteries up to 10 kVA if I wanted to. So we could run 9 or 10 or 11 kilowatts on a home completely on a 6 kVA inverter with our PV panels, with battery, without importing 1 cent from grid. Okay, that's really, really important to remember that. In fact, it's actually a 13 kVA inverter that just runs 6 kVA on backup loads when it's required. Okay, that's self-consumption mode. Most of the systems that are installed in that mode. Every so often, we also have compulsory mode. And what compulsory mode is, it's a manual override. Basically, the system does what you tell it. Okay, you can tell it to charge, discharge, or stop. We're talking about the battery operating modes at this point. You are in charge of not only the operation, the charge, discharge, or stop, but you're in charge of the amount of kilowatts that's being charged or discharged at that time as well. So maybe you want to drain your batteries for some reason, or maybe you want to charge your batteries manually for some reason. You can say, I want to charge my batteries, but I only want to charge at 3 kilowatts. You know, maybe you don't want to, maybe you're on a time of use tariff, or maybe you're on a peak demand charge or something like that. If you say, I don't want to exceed 3 kilowatts or 1 kilowatt or 4 kilowatts or 8 kilowatts, whatever it is, it will pull that power from wherever, right? Much like the forced charge mode, it will say, I'm pulling this power straight from grid and I'm bringing it in. Also, in compulsory mode discharge, if your loads are only, let's say, 300 watts at home and you've told it to discharge 2 kilowatts, it is going to discharge the rest to grid, just to be aware. Okay, it can discharge back through your grid port if you need it to. Very important here, please remember, there's no time setting on this. You can't say, I want you to charge just for 1 hour under compulsory mode, right? There's a separate setting called forced charge where we can do timing windows, and we'll discuss that a little bit later. But compulsory mode is basically like a manual switch where you can say in, out, or stop. And then finally, microgrid mode. In this mode, the inverter does not ever enter on-grid mode. It operates completely in off-grid mode. It uses the grid port only, operates in a unidirectional manner. And then your batteries can charge from PV or generator, but your loads are not fed from grid. They're only fed from the inverter. Okay, so that you would do if, let's say, you're living on a farm, you've only got solar power, and there's no grid attached whatsoever. Then you go into microgrid mode. Okay, then it stops looking with the meter for a voltage reference, and the inverter will always create the voltage. It always stays in off-grid mode. Okay, so those are our 3 main modes of operation that we would use for South Africa. We can talk about what the others do in some more of the advanced training sessions. If you want to go and have a look, there's VAPP mode, there's some other modes there as well. Okay. Let's talk about a comparison. One of the big questions we get is, oh, but we know that there's a most common product in the market. So let's do a quick comparison. We look at the 6 kVA hybrid versus the competitors. There's generally a 5 kilowatt and an 8 kilowatt version available. And most people say, I want an 8 kilowatt unit, purely because they don't know, it's that Hoover discussion. So let's talk about it. Battery voltage range. Well, we know that those are, even the ones they call a high voltage is actually only a 52 volt. So let's call it 60 volt in terms of the battery range. In our particular case, we go 80 volts to 460 volts. Right? There are 2 very big benefits to this. The first one is your balance of plant cost. We've already discussed the fact that you've got a 6mm cable red, 6mm cable black, and a 6mm earth cable. Right? What's that cost? About 60 Rand. So that's your balance of plant cost there. Everything else is provided for you. And we can do that because we're running these high voltages. Okay, we also don't need any other protection in between. It's already included in the cost. So that's the first thing. The second thing is, because these batteries work just with this inverter, the theft, somebody to come in and steal these, goes away. The BMS is not going to allow the communication with any one of 10 other battery systems which are around, right? So the theft factor, especially if you're installing these in warehouses or places which might not be easy to access or might be left alone for a while, is much, much, much lower. Okay. The second thing, max DC input power. On this system, I can put 13 kilowatt peak. Here, 6.5 kilowatt. Here, 8.5 kilowatt. Right? Again, this means that even if I have east-west facing, I can put a huge whack on, or I can run not only my home with a single unit, right, knowing that my non-essential loads will be powered in the day, so I can run geysers all day long. In fact, I can even run geysers in the evening if I want to, with the batteries that I've stored on there, right? But I don't have to add other inverters if I want to add more than 6.5 or 8 kilowatt peak, right? That single inverter will carry most homes very, very easily. What about my DC input range? Well, 600 volts versus 500 volts. So here I can run much longer strings. I know that already. In all cases, we've got 2 MPPTs, so there's no huge advantage there. But what is the huge advantage is this range. 40 to 560 volts versus 150 to 425. What this means is I start producing much earlier, I produce to much later, and the production figures that we see on these inverters is absolutely incredible. At the moment, well, I haven't seen it today, but last week at 6:44 in the morning, we could see the sites starting to pick up across the country. I'll pull up a couple of screenshots, or actually I'll pull up the live dashboard that I have access to a little bit later, and you can see some of the performance of these systems. So the yields that we're getting out of them are absolutely incredible. Okay, why is this important? Because this is your return on investment. This is the money that goes back into your client's pocket. This is the money that they get to store in the batteries that they get to use to run their house every day. And this drives your return on investment calculation again. Okay, really, really important. Startup input voltage. Again, here we're talking about in the morning when I start up, 50 volts, I'm up and running. On a cloudy day, I'm up and running. Here, 125 volts, right? So for those clients that are in coastal areas or early morning or late afternoon or east-west, whatever it is, already here we're harvesting way more energy. Okay, again, return on investment for your client. Max AC input power. Okay, remember we spoke about this architecture and why it's so critical that we do. Here, 13 kVA. I can run all of my backup loads and I can charge my batteries off grid, even if I have no PV. Here, maybe I can charge my batteries, or maybe I can run load. I have to wait, or if I'm running load, maybe I can't charge my batteries as well at the same time. So it's not even a contest, right? The fact that I could bring 13 kilowatts either from PV or from grid to do what I need to do changes the dynamic totally in terms of how many I need on site. What about cooling? Fanless here. We know here also fanless. I'm not sure if anybody's sat next to one of these things. You know, to install it in your house becomes an absolute nightmare. You actually have to find a horrible place to go and put the thing potentially far away from anywhere where you can hear the fan. In addition to the noise that it makes, it also is a point of failure, right? The fact that we've got natural cooling here is a big advantage, much less to go wrong. Okay. What about included accessories? Well, we get a Wi-Fi dongle is included in your box. We also have the power meter that is included in your box. And it's a single phase power meter with a cable. Plug it in and it'll read your entire home load plus everything else that's happening on the inverter and the batteries. Monitoring and reporting. We have free lifetime access to iSolar Cloud, which is both an app on your phone and in the web. And then the configuration on site, here is via mobile app versus a local keypad. Yes, we do have apps to operate them, but in terms of the actual configuration, it means this thing's never going to get lost. It's never going to have to be, you know, messy and clunky, and this can be updated all the time. Okay, so a huge amount of value and a huge amount of advantage throughout this entire system. Okay, so when somebody says it's a 6 kVA hybrid, well, is it really? The 6 kVA, remember, only refers to the circuits that we're going to back up and provide backup power to from batteries during grid failure. Okay, other than that, for the price of a 6 kVA unit, you're actually looking at a 13 kVA system. Do we have any questions on the comparison? Anything that I've missed?
No, it's just the one from Sean Broker about what's the average ROI on this.
Yeah. So Sean, we don't have an average ROI, and the main reason for that is certain clients are looking at different systems. So let me do a quick jump across now. I'm going to share a different screen for just a moment, and then I might have to come back to this one. So these are just different systems from around. Can everybody see?
Yes,
we'll just pick one. Let's go this top one. So what we're starting to notice is that a lot of these systems that have been installed by clients, they've been installed using the old concept, if we can call it that, the old design spec, the old design parameters. But the yields that are coming out of them are so much better than they had expected. And they're learning that there is so much energy actually available to the clients. So here we can see we're getting 3.6 kilowatts out of the PV panels. The home is using 588 watts. 3 kilowatts is going to batteries. They're pulling nothing from grid. Okay. What this looks like is, here we go. If I zoom in here a little bit on the daily yield, we can see, let's turn everything off and come back on. So if we turn on the PV, we can see they started producing 655 this morning. It's been going up. We look at their grid use. They ran on grid last night. This morning there was a little bump, 3.5 kilowatts, probably a geyser. Let's have a look at their batteries. Their batteries have been charging all morning as we go. And if we look at their load, we can see their load spiked. So what's happened here is it's very quickly pulled a little bit from grid as the PV panels have picked up, or pulled a little bit from batteries, in fact, or charged a little bit less, and it's moving on. Okay, what I want to do is show you yesterday, and I'm showing you this house, but we can pick one of 10 or 20 others and go and have a look. So in terms of return on investment, this client has got 9.6 kilowatt hours of storage. They've got, I'll tell you how much they've actually got on site. It's just quickly loading up. They've got 6.4 kilowatt peak on site with 9.6 kilowatt hours of storage. They're in self-consumption mode. That's where they are. And we can see all of their information. So let's go back to yesterday again. What we're seeing is they are curtailing and they are wasting half of the energy that they're producing every day, right? So to do an ROI calculation becomes very, very difficult for us at this point until such time as they've optimized their system. So we've got 1, 2, 3, 4, I think 4 or 5 clients now that have started this process. They've gotten to this point and they realize, oh my gosh, look how much I'm wasting. I've invested this for the cost of an extra 1 or 2 cells. I can now go and store a whole bunch of extra energy. And what they're doing is they're then bringing their ROI down from, I think, 6 or 7 years. And I expect that a lot of them are going to bring it down and actually go off grid. So what happens if we get hit with that 920 Rand cost? And they can actually say, well, you know what, I'm rather just going to go off grid altogether because I know I can produce enough energy in the day to do that. Then the whole calculation changes again. Okay, so I'm sorry I can't answer you. I think if you do a basic calculation, it's about 6 or 7 years. But when you actually look at an optimized system, I'm expecting it's going to drop down to about 4.5 years with battery storage for 10 years. If we're allowed to feed back in, depending on whatever rate they're going to give us for that, that'll change the dynamic again. Okay. Let me see if I can go back to, sorry?
Neil also mentioned that the average ROI will also differ by the local electricity tariff rate.
It absolutely will. I think, so here it actually starts to calculate a lot of information for us, where we can start to see how much revenue it's generated for the month. And you can change that for a lot of our clients. We're at about 2.68 Rand, I think, is a standard prepaid price. But there is an area where you can actually put it in. There's the tariff. So you can go in and you can actually put in a tariff. I mean, look at here, they've calculated it at 88 cents. And then a time of use, that's feed in and that's their cost. So this would be a blended cost for this particular client. You can go and you can change these and you can add time of use tariff to that. Now, please note when I say you can, only with permission. So in other words, the installer or whoever they give permission to can go and do these bits of information. Okay. Just to show you that I'm not just making this up, let's go and pick another client. There's Derek Gilmore. Let's go and have a look here. You'll see what this is doing is now it's going to say it's enabling the live data. It's going to synchronize in just a moment and turn green. There we go. Now it's bringing us live. And you'll see Derek is one of the clients that's ordered more batteries already, because we'll go and see in just a moment. See, he's already curtailing, I think. Not yet. Those batteries are still filling up. But if we go and look at some of his previous days, we'll see very clearly this day. Okay, load shedding there. Or offline there. Okay, he was doing some work there. There we can see his curtailment. So Derek's already recognized there that he's curtailing. So he's bought a new battery, new set of batteries, in fact, to capture all of this energy every day. Okay. Any other questions on here while we're here?
None so far.
Okay. Just to let you know, right now, what I'm going to do is I'm going to show some common parameter settings because we're going to talk about these in the intermediate, but I'll at least bring them up in just a moment. So there's a lot of different settings available to us. Probably the most complex part of the installation is, in fact, looking at the different settings that we have for the clients. These are the basic settings. So your common parameters are the settings which the client will have access to. And the advanced settings are the settings which the installers will have access to. And there's a much bigger list of advanced settings. Okay, so what that means, there's an advantage and there's a disadvantage to this. The advantage is the systems are incredibly flexible, incredibly powerful. The disadvantage is it does take training. Otherwise, people look at it and say, well, there's so many things I don't even know what I'm looking at here, right? So you can see how many more different options there are for us to look at. Okay. All right, what I'm going to do is I'm going to return back to this document. We're going to move away from there. We'll come back up to here. And then please, if anybody's got questions, maybe we can have some discussions. And we can continue. So we've done our comparisons. Where we spoke about what's great, what's not so great. And I think what we'll do now is we'll just run a Q&A session, or maybe just have some really introductory discussions. I'm not sure if anybody's seen what the products look like. I've just realized I didn't put pictures up of them. I see Gail. Yes, genset is catered for. We will deal with the genset integration in the advanced training. Okay, so most certainly it is catered for, but in advanced training, not in basic or intermediate. Let's have a look quickly. If I can, I'll just show everybody what they look like. Okay. So this is the inverter. If we take a look from right to left on the bottom of it here, this is your grid port that we spoke about. So this is the 13 kVA bidirectional port. Next to that here is the backup port. Right, this is where you've got your 6 kVA one directional backup side for load shedding or power outages. This section here is where your communication or your Wi-Fi dongle simply clicks in. I see this is actually not the SH. This is the SG. So this is the grid-tied version, not the hybrid version. Daniel, we just need to fix that if you don't mind. Because there's another little section here. This is the DC on-off switch. Remember we spoke about that DC isolator switch. On the SH, on the hybrid system, it actually sits on the side right here. Then on the hybrid, instead of just the 2 MPPT inputs, in between that, we've also got a battery input system. Can you not see my screen? Daniel, can you see the screen at all?
I can see the screen.
Okay. Sean, I'm not sure why you can't.
Sorry, I can. Oh, other Sean. Okay.
Yeah, no. So it's other Sean Broker. Okay. Yeah, perhaps you're frozen. Maybe just a quick restart. Okay, so on the bottom, grid port, backup port. Aha, okay, there we go. Laser pointer, there we go. So grid port, backup port on the SH, then your communications dongle, right? Then your Wi-Fi, sorry, not your Wi-Fi, your DC isolator normally doesn't sit here. It actually sits here on the side of the unit. Then you've got your battery connection there. And then these 2 MPPTs are actually shifted over a little bit on the hybrid unit. It's a slightly different look on the bottom, but the front looks exactly the same. You've got a little square block, a blue square that sits there. If it's flashing, then the unit's in standby mode. If it's solid blue, then it's in operation mode or on-grid mode, either what they call on-grid mode or dispatch mode. Dispatch mode is when we're throttling the current either on the AC side or the DC side. Either way, when it's in either the on-grid or the throttling mode, it'll be a solid blue light, and then it goes red if there's an error. So the most common errors that we see is E10. E10 means grid outage. So we see that either if there's a grid failure or during load shedding, your system will say E10. Basically, it means there's no voltage. E02 is a very common one as well. So E02 is a grid over voltage. If the grid goes out of NRS settings, in other words, your voltage goes above 253, you'll get an E02 message, and the inverter is required by the NRS standards to shut down. As I said, we can and we have and we do widen that range for a lot of clients. However, we have to be aware that the inverter is then not NRS compliant at that point. I think if they come and knock on your door and tell you you're not compliant, you say, well, neither are you. So once you fix your supply voltage, then I can return my compliance back to where it needs to be. Okay, and that's a setting that you can do remotely or from right in front of the machine. Okay, so this here is the inverter. The batteries look like this. At the bottom, you've got the base. Now, the base comes either with foot pads or with screw-in feet. If you want to raise it a little bit off the floor, for example, it's on a concrete garage floor, for example. The top section is your battery management system, which comes on the top, and that closes the circuit. And then in the side, you've got your protection, right? So this is your communications and your protection box. And on the top of here, you've got your SunClicks connectors for your positive and your negative cables, your communications cable, which also gets supplied in the box with a RJ45 connector piece, and your earth bonding point. They then go up and up the back of the top, and you connect to your inverter. Each one of these stacks is 3.2 kilowatt hours usable energy. So in other words, here we've got 3.2, 6.4, 9.6 kilowatt hours of usable energy in this battery. Okay, it's neat, it's compact. It replaces 20 kilowatt hours of lead acid plus all the cabling, plus the big DC box for your protection in between this and your inverter. And all you have is 4 cables. So your red, your black, your earth, and your comms cable that comes up in a single shaft in between and then into the bottom of your inverter. Right, so you need probably a 5 centimeter wide piece of trunking that runs up in between, and that's about it. Okay, here we've got 1, 2, 3, 4, 5, 6. So this battery bank is the biggest one that we can put on the single phase unit, and this battery bank is the biggest one that we could put on a 10 kilowatt 3-phase unit. You'll notice we're only doing training on the single phase. The 10 kilowatt units, there's just no stock, so we're not even going to focus on those until next year again. Okay, so anywhere from 3 to 6 in the stack. Okay, need compact. The entire time to assemble this entire battery bank is about 2 minutes per cell. So 1, 2, 3, 4, 5, 6. So that's about 12 minutes, maybe 3 or 4 minutes to do this part. And then the longest part is actually just putting the cables and connecting the cables in. Your entire commissioning, or is from unpacking your boxes to commissioning of the battery and inverter, is approximately 1 hour. Okay, now two big points on that. That excludes running the metering and installing the meter in the DB, and that excludes bringing your PV panels and connecting them into your inverter. But to actually put your inverter on the wall, to take out your batteries, to set them up and to connect the cables, and then to commission is about 1 hour of this kit. In other words, if you had another team prepare everything else, we could arrive on site and get it done quickly. Okay. And then, of course, PV modules. So what we do is we also have complete kits that are available. So your client can order as a single part number this whole set if they wanted to. So let's move on. We've had a look at the product offering. We spent a moment ago looking at the inverters. Sorry, I see Siluseke asked, when will we have the site? Well, it's up, it's available. You must just let us know when you want to come past. I think we do training there almost every day at the moment. Okay. And we also have Cape Town as well, by the way, not just Joburg. But so for Johannesburg, you can be in contact with myself, with Vondre, with any of the team. Cape Town, you can speak to Sean, go there, take the system off, build it back up again as is required. All right. Okay, so we spoke about the 6 kVA single phase hybrid inverter. There is a 3, a 4, or 5 kVA. We do not bring them into South Africa, even though we have requested a 3 kVA model. For large numbers, they've told us, no, it's only for Japan, the 3 kVA. We're not coming into South Africa. And the main reason for that is the cost is identical. The hardware is almost identical between the two. So to save $20 or whatever the case is for a 3 kVA instead of a 6 kVA, Sungrow is just not bringing it. And certainly not at this point. So you get a 6 kVA for the price of a 3 kVA. 600 volts DC, 2 inputs, 13 kilowatt peak, which is really, really fantastic. It's silent, it's powerful, and the performance is fantastic. Everyone that's actually got these units installed, they are seeing such great yields on their systems. Okay. Then on the battery side, remember 9.6 kilowatt hours to 25.6 kilowatt hours is usable. In our particular case, on the 6 kVA single phase, it's 9.6 to 19.6, so about 20 kilowatt hours usable. What we didn't talk about in the basic training is we can also parallel up to 4 of those stacks if we need to. So in other words, your client could have a 6 kVA, well, let's call it 13 kVA, if we take into account the non-load shedding aspects, up to 80 kilowatt hours on a single inverter. Voltage, in fact, on these, it runs up to about 460. The discharging and charging rate is 30 amps. Okay, and of course we can exceed that for about 10 seconds up to 42 amps if we need to deal with startup currents. So we can deal with startup currents on equipment, but of course, as you'll be aware, you can't maintain that for a long time. It's actually a curve that it follows, and the longer it is, or the higher it is, the shorter that time is. So you could maybe run 32 amps for a minute or 2 minutes or 3 minutes. Okay. Then we also offer modules. I'm going to take this opportunity just to talk about it. It's not related particularly to the inverters, but for residential systems, we have the 400s and the 470 watt panels. The 400s are already the Jinko Neo modules. So the Jinko Neo is the N-type module. They're more efficient. And instead of a 12-year product warranty, it's actually a 15-year product warranty now. And instead of a 25-year linear power warranty, it's up to a 30-year linear power warranty now with the new N-type. Those are the negatively charged instead of the old P-type positively charged modules. Okay. The other difference is the degradation is down to 0.44% per year. So in other words, over the life cycle of the systems, they're getting much better output on the modules. Okay, we have Jinko here next week. So if anybody wants to understand more about the new Neo or the N-type modules, please let us know, and we can arrange some sessions next week on them as well. Really interesting, and I think the big utility projects and the banks, they really like the N-type because for them it's about return on investment, and they know if they're getting 8% more or 7% more power after 15 or 20 years, that's every one of those is a rand in their pocket. Okay, the homeowner often isn't as educated about that and not quite as aware, but certainly for those of you that are doing not only residential systems but utility scale or commercial systems, it's incredibly valuable, the new N-type. And of course on the N-types we've got 545s, 550s, 600s, you know, the biggest type modules. But for the residential owners, then a full kit from us. So batteries, inverters, panels, they can all arrive. We deliver them to their house, and you just show up with the balance of plant, I suppose. Makes it a little bit easier for you as well. All right. What I want to talk about now is the wiring diagram. This is really important because of the architecture we've just spoken about. We want to make sure that we get this exactly right. So if you remember the basic training that we went on a little bit earlier, we had a few inputs, and effectively that drawing that I had up looks like this, right? There's our grid input, there's our panels, there's our batteries, and there's our backup load. So we've got the AC on the right and we've got the DC on the left. We're going to get a little bit more technical now. So on the installation, now this box here, please note, is not representative of a single distribution board. Okay, it's very important that we understand that's not a single distribution board, but it could be multiple dBs, but it's really just showing, I suppose it could be in 1 dB, but in South Africa, you might want to separate into 2 or 3. And of course, if the inverter is somewhere far away from the dB, it might even be a third one. We've got the grid feed coming in. Then we've got a main breaker, right? And then often a main meter. Now, sometimes in South Africa, this meter will sit on this side, just depends on the property itself and how it looks. But this would be Eskom or municipal meter, or your, you know, whatever meter it is that's reading the energy on the property. The SunGrow meter that comes in your box is the very next thing to come. We must not have any loads on the right-hand side, on the grid side of the meter. Okay. If we do, we cannot run this energy into those loads. Remember, it will curtail before it can reach our normal loads. So it's very important that this meter, and in fact, it says it's the meter. The meter can be clipped anywhere in the dB, but it comes with a fly lead with a CT attached, and it's a clip-on CT. So during installation, all that you need to do is unclip. On the CT itself, it says grid on one side and load on the other side, and you just clip it around your live. You could actually clip it anywhere here. It doesn't matter because they're all the same. Okay, so anywhere here is absolutely fine. Okay, it's then got a comms cable that goes back to the inverter. Please, very important to remember, no loads on the grid side of the CT. Then you've got your normal loads. So these are your non-essential loads. Here you would normally have geysers, stove. You know, this would be what would be existing in the client's DB over here. And then, of course, we feed into the inverter. Now here they show a breaker and an RCD. I have seen some clients install without this RCD here. And I have seen this feed breaker not only be a feed breaker, but also a bypass. So if you've got a bypass, it'll happen here and it'll just bypass down to here. Okay. So this here is where you will put your feed, sorry, Graham. An RCD is a residual current device, also known as earth leakage, more commonly. What it does is it detects if there's potentially a break in a cable somewhere or an exposed amount of energy that can flow through the earth or through a wall. Yeah, earth leakage. And that will trip to prevent anyone from getting injured. Okay, so then we've got our feed to the inverter, and this is our grid port on the inverter. Right? Then we've got our PV coming in. Please note we need to bond. Now this doesn't show here, but we do need to bond these battery and port via earth, right? There are connection points on the chassis of the inverter. Please make sure you bond them properly. Okay. Then coming out of the unit on the backup port, again, as it comes out, we've got the return to DB. So this is a 40 amp breaker. By the way, this can be a 6 mil cable here because we're going to carry no more than about 30 amps. Okay, maybe 32 amps for a short amount of time, but generally a 6 mil cable here is fine with a 40 amp breaker. Here you can use a 10 mil cable. You can use a 63 amp breaker here if you want to. You could use a 40, but just be aware that you're then limited to how much you can export this way. So what I would do is I would calculate that based on the amount of PV you've got and whether you expect to be able to feed back. Okay, again, RCD here, you need to have protection here for any plugs on here. This earth leakage will not support here if you're in a load shedding condition. So please make sure that you've got RCD here as well. Okay, so this is any plugs that are on your backup loads, and this is any plugs that are on your normal loads. Okay, here again, you could split this and you could have another section without your RCD that's feeding lights. Okay, and then here you see they've used 2 breakers here. You don't have to use 2 breakers. You could generally use 1 if this is then going into another board. Then you would have another breaker in the other board. Okay. Now this is for TT systems. Okay, in South Africa, most of the wiring that we use, especially in residential, is TT. So Terra, earth. Okay, if there's an earth spike there, then you're running with this type of a system. What's really, really critical, please. Okay, so you're using TNS on yours, hey? Okay. Often we see TNS often in commercial buildings as well. If you look in the drawing, in the installation manuals, there is a TNS as well. You can use the same thing for that. You're just bringing earths from here too. Okay, so you're welcome to go that route too. Okay, this is really critical. Please use separate neutrals. Okay, we've seen quite a lot of sites. The first thing that happens is you start seeing lights flickering. The second thing that happens is the system's not providing all the right amount of power because it's confusing neutrals between the two. When this drops, all of a sudden, are we floating? Are we where? So please make sure that you have separate neutrals on backup mode or on both grid and backup. Okay, really, really important. You can have common earth here, you know, your PE, but please look how the neutrals are separate. Okay, if they don't, normally the very first thing you see is lights start to flicker, especially during transfer times, and not all normal lights, but especially if you've got LEDs. And the easiest way to tell is it's LEDs with poor drivers are the things that'll start flickering first, and that's a really great way to say, oh well, maybe the first thing I must do is just go make sure my neutrals are separate. Okay, if we don't do that, we can end up thinking we've got a problem on site or with the hardware. The second thing, which we've already discussed, is please ensure that the panels and the batteries are earthed to the chassis. Okay. And then the third thing, please make sure that there's no loads, which we've spoken about between here, because it uses the reference voltage. Oh, sorry. This is not about no loads on the right. This is about where we get the power for this. Okay. Take the power to this, please, from the grid supply side. When we did our first few installations, we thought, oh, it's a great idea. Let's, there we go. So when you put the power here, please take the power here from this supply line. In other words, from the grid supply line or the grid breakers, right? When we first did the installations, a couple of them, we thought, well, let's take the power from backup. That way the meter will always have power, right? The problem then is it doesn't know that the grid has fallen away because the voltage reference remains. So the relay keeps opening and closing because it doesn't quite know that it's supposed to be in off-grid mode. Okay, so very important, please power this from this line, not from this line. The question then comes, well, do I lose communications when the grid goes away? The answer is no, you don't. And the reason you don't is because the batteries provide power to the unit. And even though it's not measuring anything coming in from grid anymore, it knows that it's got no voltage. It's still seeing the fact that there's no voltage there. And the communications dongle is powered from this side. So it's measuring how much energy am I getting from battery, how much energy am I getting from PV, and how much energy am I pushing to my backup loads, and it still reports all this data to you. The only data that's then missing is this from grid, which is 0. Okay, so you don't suddenly stop getting information. You actually keep all that information going. Okay, any questions? No. Okay, great. Let's move on to the next slide. So, system parameter settings. Now, please note, yes, sure, go ahead, Adeboye. You can unmute yourself and you're welcome to ask your question.
Adeboye, we've given you access to unmute yourself.
Oh, thank you so much. Good morning, everyone. So
Good
I
morning.
wanted to ask the sun-grown inverters here. The grid input and output, is it a bi-directional one or is it just one directional one?
Great. So the grid port is bi-directional. The backup port is only one direction. But the grid port, we can export through that same port, and we can export up to 63 amps.
Okay, nice one.
Okay, great question. Thank you. All right. So I'm going to talk now about parameter settings. These parameter settings that we're going to use are for the 6 kilowatt single phase unit, and they're for the 0 export requirement that we face in most places in South Africa. If you are allowed to export, we'll discuss 1 or 2 settings that you can change very quickly to allow you to export. Okay, but this is for 0 export as the primary function for now. Okay, so when you first commission the inverter, it's going to come up and it's going to say initial grid. We go down and we select South Africa. Then I think on firmware version 26 and up, it gives us NRS as an option. There are some cases where if you're running version 25, it's completely stable, it's absolutely fine, but it just doesn't ask for NRS at all. It just assumes it. Okay, so if it does ask for NRS, then you just select NRS as opposed to RRP. RRP doesn't have a lot of settings preset. NRS has all of our local settings already preset. Okay, feed-in limitation, then we enable feed-in limitation value. Instead of setting to 0 and 0 like we would in disable, rather set them to 0.01 kilo and 0.1%. The reason we recommend that is there can be no divide by zero calculations, which might return an error at some point. So if we use these settings, it actually goes to zero. We don't actually export any. It assumes it is zero, but any calculations uses tiny amount. Okay, so this feed-in limitation we turn on. This is the upper amount of energy that it's allowed to export, 0.0. This is actually kilowatts, not kilowatt hours. So 0.01 kilowatts, in other words, 10 watts, you'd be allowed to export, or 0.1% of the installed PV capacity that we would put. Okay. Backup mode, you set to enable, and then reserve state of charge. You can choose what it is for your client. I've just put 35% there as a recommended amount. If it's in the middle of a load shedding season, you could set that to 40 or 50 or 60% if you wanted to. And we'll explain what each of these means in a little bit. We've got a lot of clients that say, well, 35% should be good to start, or 40% or 50%. By the end of today, you'll be able to select that one as you like. Okay, so these are your initial grid settings. So really, as you turn the inverter on the first time, it'll come on and it'll have a little flashing blue light. The process is to first connect the Wi-Fi dongle to their home network. And the way that happens is as you open the app, you connect to it and it says find a Wi-Fi network automatically. You say find Wi-Fi network. You'll see the homeowner's Wi-Fi network. You click that one and it asks you for the password. You put the password in, and what it'll do is it'll then link the Wi-Fi dongle directly to the homeowner's network. Okay, once that's happened, then you're no longer linked to the homeowner's network. You're actually linked to the dongle. It'll then say initial grid settings. Now, what happens if there's no network, right? Then you can say skip the Wi-Fi connection. You can just do the initial grid settings, and then we can come back and do the connection later on once you've got the password or once the signal is in place. Okay, but in probably 9 out of 10 cases, there's already Wi-Fi on site and present these days in the homeowners' houses. Okay, so these are the initial grid settings. Once these are put into place, the blue flashing square on the front of the screen should go solid, and you'll have a solid blue square. It'll then flash through some different options. So it looks at power, your AC power, it looks at your battery state of charge, which is normally around 20% when you unpack the box for the first time. And it looks at how much PV power production is available. And it just sort of scrolls through those on the screen. As you start up, those should all be on 0. Right, so you'll see they say 0, 0, 0. Because we put in NRS, even after it's gone solid blue, it'll wait 60 seconds before it actually starts to do everything, before it starts to close the circuit on the battery, before it actually starts to come live again, right? That's required, and it then goes from standby mode into starting up mode, which takes another, say, 60 seconds or so, and then it'll go into on-grid operation mode. Okay. So now what we're going to do is we're going to switch to a separate sheet, and we're going to walk through some of the settings. Will you let me know when you can see the new sheet?
From our side, we can see James.
Fantastic. Okay. This document we will share. We're just finishing 1 or 2 things on it, and we will share the complete document in the coming days with everybody. It's just some helps and hints on when you're connecting them, what to connect. You know, so in the box is a white cable, a black cable, orange, white, orange, and it tells us where to install them. So we'll come to this when we actually do the physical installation training. Then basic training, we've spoken about the different modes: self-consumption, compulsory mode, and mini grid. We've also then just spoken about some of these settings which you would like to do. What does backup mode do? So I haven't explained that, but let me explain what backup mode does. Backup mode is there to tell the system, do not just dump all your power into the grid. Okay, we have to save some for backup. It's telling the inverter that there's a battery system attached, that there's a backup mode, and do not dump more than the reserve state of charge into our loads. Okay. So in other words, if we say 50%, you can feed back through your grid port. You know, we had that question, is it bidirectional? Yes, it is bidirectional. I can run my geysers, I can run my stove, I can run all those loads through my batteries, by the way, down to a certain percent. Why? Because if it's 5 in the morning, I would rather use, if I've got extra battery power, use some of my battery power to heat my geyser in the morning than to buy energy from the grid, knowing that the sun's coming up in just a few minutes. Okay, so that's what this backup mode and reserve state of charge is for. We can also, through the reserve state of charge, tell it, well, don't heat my geyser so that if I've got load shedding at 8 o'clock, I'm going to have no power left. Okay, so that's the function of these two pieces here. All right, now we're going to go into the common parameter settings, and then we're going to go into the advanced parameter settings. What I'm going to talk about is only the items in blue. You'll see in the menu, when you go into the menu, there are different options that you can click. Those are here. Then in the menu path, as it goes down, this is your next setting. When you click on that, here's what you can set, or an option that we say you should set it to, and then some notes to say, well, this is what it actually does. Okay, so there's a lot of stuff we're not going to deal with today. We're only going to deal with the stuff that's highlighted in blue today, because these are the primary settings which you should go through when you commission the system for the first time for the client. It shouldn't take you much more than 10 minutes to do them all. Okay, so if the wiring is correct, once everything is on the wall and you do it, your commissioning process is 10 minutes. Okay, so start, stop, we put it to boot stage. The other option is shutdown. If you're going to do any work on it, then please go to the shutdown, but normally it must say boot. Protection parameters comes as standard in 3rd level. Connection time 60 seconds. This is through NRS. Under the power control module, backup mode, enable, and reserve state of charge, we spoke about that. Set it to 35, 40, 50, 60, 70, 80, whatever percentage you like to have there. Then we go to the energy management mode. Weekday discharge. So this allows the battery and the panels to discharge times during self-consumption mode. So in other words, you may say, well, I don't want to use my system at 3 in the morning for whatever reason. You know, I don't know what the reason would be, but maybe you don't want to use the system for whatever reason. For residential, we don't have time of use tariff. So for us, set it from 00 to 2400. Okay, start and end time number 1. Basically, what this is saying is 24 hours a day, work in self-consumption mode. The panels can work, my battery can work, you know, cycle properly. So 00 to 2400. You do have a start and end time number 2 as well. You can set those also 00 to 2400. And then instead of just weekday, you can also say, well, I want a different section for weekends. So maybe in a business, you say, well, over weekends, I don't want to do this. I recommend you just leave weekends on as well. So basically every day, all your weekdays, all your weekend days will do the same. Forced charging. Okay. Forced charging uses any source, right, of energy to charge my batteries to a certain state of charge. Okay. If I have forced charging disabled, what's going to happen is the batteries will not recharge to your minimum state of charge that you've set, except by solar power. So for example, some clients say, well, I'm happy to drain my batteries to 20% or 10% overnight. I'm not going to set a forced charge because I want my solar panels to work the entire day to charge them back up. Other clients may say, well, I want to force charge my batteries from any source, no matter what, to 40%, right? Or 35 or 50% or whatever it is. In which case you would enable it. you would say, let's give you a great example of these next few sessions of the forced charge. Let's say every day you want to use forced charge from 4 o'clock to 5 o'clock in the afternoon just to top your batteries up to 100% so that you can run through the whole night. But you know that at 4 p.m. maybe the solar power isn't as much. So there we would enable every day my forced charge to start at 1600 to end at 1700, and I want you to charge it to 85% or 80% or 60% or 100%, whatever it is. And you can actually do this twice a day. Okay, remember, this will not only use solar power, it will use solar power and grid to charge. Okay, you don't have to go and reset this every day. You set it once and the system will just do that. Any questions on this? I can't see my screen, Daniel, so if there are, maybe you can let me know if we've got any questions on it.
Nothing yet. Gail just asked, can you install the Sangre inverter, which we already answered. Can you install the Sangre inverter and battery energy system without solar in cases where customers want to stagger the payments over a few months? So we said yes, you can.
Yeah.
But I think you can give us a bit of an in detail explanation to that.
Absolutely. Yeah, you absolutely can. You absolutely can. In that case, what you would do is you would just set your forced charging up, or you would set your minimum state of charge up to whatever level you want. So I think in my house, I've got this set to 50% or something like that. And the moment it drops below that and grid returns, it just recharges it to that level. Okay, so you can do it one of two ways if you don't have PV panels. Reserve state of charge, in which case it'll just pull from grid, or forced charge every day and you can charge it to 80, 90, 100%, wherever you want to do that. Okay, what's really important to remember is your forced charge window, your time slot, this one, takes preference over your discharge time. So in other words, even if, let's say you've set forced charging till 6 o'clock at night, and you set it to 80%, and maybe it reached 80% at 4 o'clock in the afternoon, just from solar power, for example. The fact that you have forced charge set and active, even if it's at that level, you will not cycle your batteries until you're out of that block, because it's telling your inverter, make sure my batteries are at this level by this time. Okay, that's very important to remember. Otherwise, someone's going to come and say, oh, my batteries aren't discharging. They're possibly not discharging because your forced charge window, even though they're at 100% or whatever it is, might still be in effect. Okay. Digital out configuration, we're not going to do today. We'll discuss that in more advanced sessions. These advanced, now this is more advanced settings. So these are protection parameters. As I said, once we come to some of these, we'll start dealing with what happens when we've got grid over voltages, where grid often hits like 255 volts. Okay. Then, so that's protection parameters. Power control. Okay, now this is quite important. So now these numbers here are the numbers that they appear on the menu. This is actually changing slightly for firmware version 28 because there's a few new options. There's the option to charge batteries individually out in firmware version 28, which didn't exist before 26. So the numbers might be slightly different, and that's one of the things that we're just working on to get them right. Under power control, there's active power gradient control. Okay. Active power is not as we normally know if you're an electrical electrician or electrical engineer, where we normally talk about active and reactive power. This active power on the Sungrow inverters really talks about the PV power coming from the solar panels. So when we start, we will enable our active power limit and we set that to 100%. In other words, if we want to feed back any active power to our loads, we're allowing 100% of our PV panels to feed back to those loads. Okay, so that's what this active power limit refers to. This active power gradient control is referring to how fast are we allowing the panels to pick up and slow down. right? And the main reason they don't just say, okay, come in at 100% and go off at 100% is in homes, you've got things like geysers kicking in, stoves kicking in, you've got kettles and things. And you don't want this, as the geyser kicks in, you don't want the panels to throw a huge whack at your IGBTs. You can end up damaging your inverter. So they put a rising and a declining gradient on. When it comes out, it's very, very conservative. Okay. So what happens is a geyser kicks in, all of a sudden you see the system pulling from grid, even though you've got plenty of PV power. And then only, a minute later, you see your panels pick up to cover that. What we recommend is change this to 50% per minute, and you'll see that whole process speeds up very, very fast. Okay. In fact, you can actually change that as high as, I think, 6,000. So in other words, you can change that to 1/10 of a second. So you could match it absolutely exactly. Please don't change it to 6,000 because you're going to put your inverter under stress. 50% is normally excellent. We see great results with that. Okay. Your installed PV power. This is the kilowatt peak that you've got installed on the site. Okay. So this will be different for every client. You might have some clients with 4 kilowatts, some clients with 12 kilowatt peak on the same system or on a similar system. Feed-in limitation, this is what we do for that zero export. Please, if you disable this, you're just going to feed back all the time. If you've got a prepaid meter from Conlog, it's going to go into tamper mode. So that you can get an LLR to remove that, but please just be aware that the prepaid meters absolutely don't like it. Eskom's normal meters also don't like it too much. If you've got one of those rotary meters, well, we're required to tell you that you're not allowed to feed in, but we've got clients that suddenly, for some reason, this keeps changing itself automatically. We're not sure how. Set these limits to 0.01 kilowatts and your feed-in limitation ratio to 0.1%, and we see no feedback then. This one here, number 15, the rated power of the original system. Okay, this is if there's an already installed string inverter on site that's running, say, I don't know, 3 kilowatts, 6 kilowatts, 8 kilowatts, whatever it is. This is where you would put this. This is for an AC coupled system only. If it's your PV that you're putting on the roof and you're plugging straight into the hybrid, this stays at 0 and you put it in your installed PV power there. So this installed PV power is the power that's feeding into the MPPTs on the inverter. This here is if there's an AC coupled system. Okay. The rest of these are not applicable for today. Meter communication detection. Enable this, please. This is what allows the meter to detect for that feed-in limitation. If you disable this, okay, it will stop exporting through your grid port altogether. It will still operate as a backup system only, but it will stop sending any power back through to feed your non-essential loads. Okay, so as long as your meter's there, enable it and it'll run your non-essential loads. And then forced AC bypass, this is important because it allows your inverter to run loads. So instead of coming in, converting to DC, then all the way back and then converting to AC back for your other loads, the forced AC bypass allows you to bypass and go straight from your grid port to your backup port. Okay, so you enable forced AC bypass. Okay, this is a really, really cool feature. If you install your meter backwards or your CT backwards, you don't have to go to site to turn it around, right? Straight from the app, straight from your computer, whatever you do, you can log in. Oh, we might have reversed the meter. You can, well, it says close here, but you can just enable it. And what it'll do is it'll automatically swap the direction or it puts a negative in front of the value that it reads. And then your system will come live again. The easiest way to tell if you've reversed the meter is your PV production and your load production will match exactly. You will not on the app see your battery and your backup load feed. You will only see a grid and a PV line. Sorry, not a grid. You will only see a load and a PV line, and they will match exactly. You will not see battery and you will not see grid. The moment you see that, it's an indication, oh, I've installed my meter backwards. Just change this meter reverse connection and you'll see all 4 units come live again. And I'll show you what those look like in a moment. Okay, then finally, we've got energy management mode. Set that to self-consumption unless you want compulsory. See, here's some of the others we were speaking about. FCAS, VPP, external energy dispatch. None of these are applicable for us in South Africa at this point. So we only use self-consumption, compulsory, or microgrid. If you click compulsory mode, you'll see your charging, discharging, and your charging, discharging power will become available to you. In any of the other modes, they're not available to you. External EMS heartbeat and battery first. These are requirements from the Australian market. So we don't set anything for these here. And then finally, your battery parameters, 100% down to 5%. You can leave it at 85%, 90%, 100%. It really just depends on how much of your battery you want to use. Remember, this is different to your reserve state of charge. This upper limit and lower limit are the limits to which you're allowing the system to use your batteries. The reserve state of charge is a level to which you set your self-consumption mode and how much of that energy within this range you are keeping for backup only. In other words, once grid falls away. Okay, so those are 2 different modes. Any questions on these settings?
Hi, James. Nothing yet.
Okay, great. We've still got a little bit of time. So what I'd like to do is, if I can, we'll just go and pick 1 or 2 live sites. If I can find, there we go. So, I mean, let's go and look at some live sites. Maybe we can pick one. Now, normally you can't see all these sites. Obviously, I have access to this. You will be able to see your own sites that, number one, you've installed as an installer, or your homeowner will be able to see their sites. Okay. On my settings, I can see advanced as well. If you're the installer, you will be able to see the advanced settings. If you're the homeowner, you will not be able to see the advanced. You will only be able to see the common parameter settings. Okay, so let's scroll down on Steve's. Here we can see an example. So in the morning, the sun comes up. So turn everything off and have a look at what happened at his house. So in the morning, we can see they wake up. That makes sense at about somebody has a shower, brings in a 4 kilowatt element. Then they go off, and then throughout the day, there's kettles turning on, maybe a washing machine or so on. So that's a normal household load for the morning. If we look at what's happened to their batteries, they've been charging. If we look at their grid in the morning, they came up. They perhaps didn't have enough time to. Gail, I see your question. I'll answer it. So here we probably didn't have enough PV power to run the whole lot. So we pulled in from grid. Let's have a look at PV. So we've noticed his PV has picked up. It's covered all of his load. So all the rest of this we expect to go back to grid, except for the fact, why did this suddenly drop off when we know there's more? Because his batteries reached a high point. His batteries are now fully charged. If we go up, we have a look. Yes. Okay, his batteries are fully charged. And now he's just curtailing and running just what is required. Why do we see a few watts coming through here now and then? Every so often we'll see 20 watts, 50 watts, 100 watts. It doesn't last long. It just pops through. The reason we see that is because the system is looking for a reference voltage and a reference frequency, right? So it's always pinging and making sure that it's there. Okay, let's pick another site. Same sort of thing there. We see a small reference feeding here. The rest is going to charge batteries. Those batteries are not fully charged yet. So as we expect, here we can see we're still producing power. The batteries, however, have probably reached, let's say, an 80 or 90% mark, and we've gone from bulk into absorb phase. So if anybody's familiar with the battery charging phases, there's bulk, absorb, and then float. So we've gone through, we've done the bulk, we're now in absorb, which is a smaller amount. You see that would have happened at about 95, and now it's just going to push 1 kilowatt in for probably the next hour or so, maybe next hour, hour and a half as it goes through. Okay. So any questions on this? Okay, Gail asked a question about, can we go through about how to handle Eskom voltage? Let me go to my home site. Okay, so here you can see my batteries are at 87%. I don't have PV on this because I'm constantly taking it apart and pushing it in. I'm using 241 watts. It's going to update us in just a moment, and we'll see what's actually happening in the house now. There we go, 207 watts. So we're currently using this purely as a backup system. So there you can see geysers kicking in as it goes, which is what is expected. There's no PV on, so I'm not reporting anything here. Let's look at settings. Okay. I have to select a device. So I'm selecting the inverter and I'm going to advanced settings. At my house, the voltage from 2 Thursdays ago pushed up to 254. There was an issue on the transformer in the neighborhood. They did some repair work and it's pushed the voltage up, and I got all kinds of faults, lots and lots and lots of them. Protection parameters. So what we had to do is come through here and make some changes to it. I'm going to look at a task list. So normally I can make whatever changes I want to here. We can see what the actual values were, and as we change them, we can make different, each one brings up different options for us. So you see it gets quite complex. I've got protection level 1, I've got grid imbalance support, I'm not running a zero current trigger. But what I'm going to do is I'm going to simplify this by looking at a task list of everything that's happened on here. And you can see I've made some changes. Let's have a look, view here. And I'm going to export this just so we can see what it looks like. You see how many different settings there are, which is why generally a lot of these will only get to in advanced level. Okay, let me see if I can expand this a little bit more. Okay, here's this high voltage ride through that we were looking at here. Yeah. So what I've done is on my high voltage ride through, normally, if you remember earlier, it said protection level is 3 for South Africa, right? That's the standard, is protection level 3. I've changed my protection level to 1. My high voltage ride through for NRS comes in at 253 normally. Okay. Here we can change this. So I've actually boosted mine up. You can set it anywhere from 260, 270, wherever you want to set it to. And then we set it for, this is in milliseconds. Okay. So I've reduced the protection on my own home system. I've put the system at risk, but I know that Eskom is coming to have a look at it. And I've changed those settings so that I can ride through without causing trouble and without having my system shut down. The problem with the grid over voltage is the system's actually required to go into standby mode. which is fine because it'll leave the relay closed. So as a homeowner, you may not know, but the problem is you'll get an error. And if we have load shedding, or if there's a problem, that inverter is going to shut down, right, to protect itself, because we don't want to damage the thing. Okay, so all of this are within your control. You can change any one of these values. You can also set where does it come back and where does it reconnect. So in my particular case, I've got it. See, here's your standard 253 to 251. In my case, I've set it to, I think, 254 or 253 that it reconnects. All right. So where you would do that is you would come in here. I would select 1. When I select 1, I can go and I can put different values in there. It's currently set to 276 for 2000 milliseconds. And I mean, you can set it for a huge amount of time. Be aware, if I'd set this for 276 for 1.44 million seconds, I'm going to break the unit, right? And then when you come to a warranty claim, we'll see what's happening, and they're going to say, hang on, why did you do that? You know, so try and keep it within your limits. 253 should be your limit. If I go to protection value 3, it's also got 276 and 291. Okay, but should be about 230 plus or minus 10%. If we go on the low side, it'll be 230 minus 10%. So if you have low voltage in the area, have a look. Should be about 195. Okay, so you can ride through these. This 10-minute over voltage protection, please be careful of this, because if you enable this, right, the moment it detects that, it's going to shut down, and it's not going to recover when your voltage restores. It's going to wait for 10 minutes before it even starts checking again. I hope I'm not confusing or losing anybody on this. Okay, normally we'll cover these things under more of the advanced settings. Gail, does that answer your question? Are you happy to see where we would do that or how we would do that? Great. Okay, I'm not going to save any of these, but as you can see, there are a massive amount of options that we've got in the advanced settings. The goal for me, though, is we've got to get the wiring right and the settings right. The 6 kilowatt units they're bulletproof. We've thrown pretty much everything at them. The 10 kilowatt 3-phase units we've had quite a lot of problems with. I think both from an installation perspective and from a settings perspective, where we're right on the limit in a lot of stuff, and we haven't done training like this before. So on the 10 kilowatt stuff, I think, you know, the 3-phase stuff is a lot trickier, and the settings are far more important. I think on the 6 kilowatt stuff, go in, set the settings like you've got them, and the sites are just up and running and working perfectly. Okay. So to everybody, thank you very much for your time. We know it's a quick and fast introduction. If you would like, give us a shout. If you want to put one in somewhere, give us a shout the first couple of times. We'll be glad to help you. If you'd like to come in and take them, make them, break them apart, put them back together again at our own places, you're welcome to do so. You know, feel free to use us, to look at us. We've got stock. I know there's a lot of shortage of stock at the moment around the market. I think we just landed about 300 of the systems. Daniel, are they GRN'd already, or are they available? Can we release them?
They are available. They're ready to be released with battery units as well. So we are ready for them.
Great. So we do have stock, and yeah, we're ready to go. Thank you for your time.